In this video, I want to go over solving multiple step equations. Just like in solving one-step equations, we still have one rule and one goal. And our rule is that we're always going to use the inverse operation when doing it. So if we see that x is being multiplied by some number, we're going to divide by that number. And our goal is to isolate the variable. Isolate the variable meaning it's going to look something like this. X is equal to 5. Okay? The number, or the variable x, is alone on one side. Okay? So we're going to use 3 examples. We're going to have an example of combining like terms, then a fractions example, and a decimals example. And this decimals example is, we're not going to use a calculator for it. No calculator. Okay? Here we go. Let's dive into the example problems. I want to combine like terms here. So I have 6 is equal to 7x minus 18 minus 4x. Okay, so I have two, we'll say, sets of like terms. We have things that are being multiplied by x and numbers. Okay, just whole numbers. Okay, so the first step here in solving this for x, remember that's what we're doing, our ultimate goal is to solve for x, is to combine the like terms. I'm going to combine my x's first, and I'll get 6, sorry, let me make that blue. 6 is equal to 7 minus 4, so that is 3x minus 18. Okay? I still have my whole numbers that I need to combine. So in order to get this 18 onto the other side, I'm going to add 18 to both sides. Okay, if I add 18 to both sides, I get 24 is equal to 3x. All right? Now, this is just like a one-step equation. I see that x is being multiplied by 3. So what am I going to do? I'm going to divide both sides by 3. And when I do that, I get my final answer of x is equal to 24 divided by 3 is 8. Okay, now on to the fractional example. So I have 5x over 2 minus x over 3 is equal to 1. And in this case, I'm going to, we have to combine our fractions, right? And we have 2 different denominators. If you remember, when you add or subtract fractions, you have to have a common denominator. And the easiest way to get that common denominator is to just multiply the 2 denominators together. So if I do that, 2 times 3 is equal to 6. Okay, so 6 is now my common denominator. I'm going to put both of my numerators over 6. Okay, oops. Okay. Now, the issue here is I have to change my numerators, and I'm going to do that by asking myself this question. What did I multiply 2 by to get 6? Well, I multiplied it by 3. So I'm going to have to multiply the numerator by 3. So this is going to be a 15x. All right? And I'm going to ask the same question here. What did I multiply this 3 by to get 6? The answer is 2. So I'm going to multiply the top here by 2 as well. And now I can combine these like terms, okay? Now they have the same denominator, so I can combine them into, I'll do it out, 15x minus 2x over 6. And then I can combine like terms here. I have a 15x and a negative 2x, so that is going to be 13x over 6 is equal to 1. All right. Now we're at a one-step problem situation. I can multiply both sides by the reciprocal of 13 over 6. So I'm going to multiply both sides by 6 over 13, right, the reciprocal. The reciprocal is just the fraction flipped, okay? It's the multiplicative inverse, okay? Here we go. This cancels out. This turns out to be 1. So we're going to get x is equal to 6 over 13. Now on to example 3, which is an equation that contains decimals. And this is a particular way to do it. You don't have to do it in this way. But if you'd like to think about it, if you want to remove those pesky decimal signs or decimal points, what you can do is you can multiply both sides of the equation by a multiple of 10, okay? So in this case, I know that the number that I would like to multiply both sides by is going to be 100, okay, which is 10 to the second power, right? 2 zeros there. So that is going to make everything shift to the left of the decimal sign, okay? If I multiply both sides by 100, okay, 4.2 times 100 is 420. Okay, 0.05 times 100 is 5x, sorry. And 1.25 times 100 is 125. Okay, so now we have numbers that are a lot easier to work with. Okay, so now what I want to do is I'm going to need to subtract 420 from both sides. In doing that, I get negative 5x is equal to negative 295. All right? Now, this is a one-step equation. X is being multiplied by negative 5, so I can divide both sides by negative 5. Okay? And I'm going to get that x is equal to positive, right, because we're dividing a negative by a negative, positive 59. Okay? And that is our answer.